Alright, so this is step 2 of that problem, expanding using de Moivre's theorem. So if you remember our last video, we converted to polar form. We took root 2 plus root 2i to the 4th power and converted it to polar form. That gave us 2 times cosine pi over 4 plus I sine pi over 4 to the 4th power. So that was our last video. So now what this video is going to tell us about is de Moivre's theorem. And it says that if I have a complex number and it's z in the polar form, so z is equal to r times cosine theta plus I sine theta. Well, if I want to raise that complex number to a power, like the example that we're working on here, all I have to do is take the power that I'm raising it to, in other words, z to the whatever power it is, and plug that power into r to the nth power, into the argument of my cosine, and into the argument of my sine term. So in our case, we were talking about the 4th power. So that means that n is just going to be 4. So we can go through and plug that in. So we can say that for our equation, z is equal to our polar form, n is equal to 4. So we can come down here and say that z to the 4th is simply 2 to the 4th power cosine of 4. I made it 4 over 1 to make the multiplication easy for me, but essentially 4 times pi over 4 plus I sine 4 times pi over 4. So I worked it out, and it turns out that 2 to the 4th is 16. That's 2 times 2, which is 4 times 2, which is 8 times 2 again, which is 16. Cosine of pi is just equal to 1, or rather to negative 1, plus sine of pi, which is equal to 0 times I. So at the end of the day, the answer to this problem here is just z to the 4th is equal to negative 16.